Hello, this is Dr. Mears. Today we're going to be writing equations from a table. These are two examples that I was talking about after we filled in our ISN notes on writing an equation from a table. I wanted to give you two examples that I went over with you again, so there would be a total of 4 examples. So here's 2 examples. Let's do these. If you notice in your ISN, you do have 3 steps. The first step was to find the constant rate of change. So you had to go through and you had to find the difference of the y's. So here we are decreasing by 3. And as you can see, the pattern extends all the way. Here we are actually increasing by 4. Our numbers are getting bigger by 4 here, and the pattern does increase. So our constant rate of change is the change in y over the change of x. So let's look, here's y. Y is 4 divided by, here's x, negative 3. So be careful of that negative. I like to put a box around it. In our steps, we need to find constant rate of change, and we also need to find our y-intercept because we need, as I said before, m and b. We have m, let's find b, our y-intercept. When we find our y-intercept, we have to see where x is 0. So let's find x is 0 here. I see x is 0 right here, so let's put a box around this point. We have to find x equals 0. What is that y value? That y value is negative 2. So let's write b equals negative 2 and put a box around it. We have those two things that we need, m and b. So let's write our equation. Y equals 4 over negative 3x minus 2. Now be careful when writing this. The x can go next to the fraction. The x can also go in the numerator, 4x divided by negative 3 minus 2. The x cannot, however, go in the denominator. That is a no-no. I will mark you wrong. I will not look at any work. I will just mark it all wrong. So it's either going to go directly next to the entire fraction, like I did here, or it can go on top with the 4. Okay, our second example that we have down here, we're going to do the same things. We are going to find our constant rate of change, which is our m. We are going to find our y-intercept, which is our b. And we are going to substitute m and b into y equals mx plus b. So first, let's see what our pattern is. We're increasing by 1, and as you can see, we're increasing by 1 all the way down. Ooh, here, plus 0. Plus 0. We're not going anywhere. We're just adding 0 every time because we keep getting to that same number, which is 4. That's interesting. Let's see what happens when we do our slope. The slope is the change in y, which was 0, divided by the change in x, which is 1. When we divide 0 by 1, we do get a slope of 0. That's absolutely fine. So we know that our slope is going to be 0. Let's find our b. Our b, we locate where x is 0, what our y value is. Our y value is 4. So our m is 0. Our y value, which is our slope, our y-intercept is 4. It is positive, so plus 4. So our equation is y equals 0x plus 4. We can also write this as y equals 4. That's also fine because this 0 times x is going to be 0 and 0 plus 4 is 4. So you can write it either way you want. I will take it. It is correct. So this is a special case because we have 0 as our slope. I wonder what it would look like if we had undefined as our slope, and that's for another day. I hope this helped. This was 2 more equations of writing an equation in slope-intercept form. 2 more examples, I should say. Thanks. This is Dr. Mears. Hope it helped.